and we were like, oh shoot, we have done a disservice to our students. So now we get into the habit of at least showing them to you. They usually do them with no like transformations or anything crazy on them or anything like that, but they exist. You need to know they exist. Okay, let's start with our tangent graph. Exactly the same way we did our sine and our cosine graph, so we need to know, and notice this table is significantly longer than your sine and cosine graph, because, well, that's what we do. Okay, let's start at 0. So at 0, what is tangent? Okay, so I just have to think about it for a second. So tan theta is sine theta divided by cos theta. So here, like if I'm looking at the unit circle, that is 1, 0. Okay, you're right. Yes, you're right. It is 0. At pi over 4. 1. At pi over 2. Oh, this is a tricky one. So at pi over 2, we're up here, and that's going to be 0, 1. So now my 1 is on top and my 0 is on bottom. Not defined. Impossible. Undefined. So I'm going to call it a UD, undefined. Everybody okay with that? Because this is the 1 over 0 for the ratio. So that can't happen. If you put in your calculator, it's going to give you an error. Okay, we're at 3/4 pi. -1. Okay, so for those of you who are like, I don't know how she's getting these points, remember that when it's a pi over 4, that's when it's root 2 over 2 and root 2 over 2. That's the only place that the x and y coordinates are the exact same, and if you divide something by itself, it's 1. So anytime you have a denominator of 4, your tangent is going to be 1 or +1. Okay? At pi, what's happening? 0 again.
0.
Because it's the 0 over -1. Does that make sense?
Yeah.
Is it okay if I write these? You guys will know what those things mean beside it?
No.
Perfect. 5 pi over 4?
1.
+1. 3 pi over 2? Undefined. Ooh, forgot my stick on my U. 7 pi over 4? -1. 2 pi?
0.
Okay, so do you guys see the pattern?
No.
0, 1, undefined.
-1, 0.
-1, 0, 1. So what do you know? Right? Like you know that I've got a -1, a 0, and a 1, undefined. And then a -1 and 0. What would the one after that be if we kept going? +1, right? And then what would come after that? Undefined. So again, a table of values you can totally use. I always encourage when you're not sure where to go to use a table of values. They're always helpful. But if you can see the pattern, it goes a little faster. Okay, so we have a +1, we have a 0. What's -pi over 4? -1. We'd be in quadrant 4 and I know my x and y are different. Pi over 2, so we're here. Undefined. And we also know that we have a 1, 0, -1. So what's happening at 3/4 pi? 1. And then what's happening at pi? 0. And then what's happening at -5 pi over 4? -1. And then? Undefined. And then? 1. And then? 0. Okay, so you just follow the pattern, right? You stop even like doing the math or thinking about it or where you are in the quadrants and you're like, this is the pattern. I just follow the pattern. And that's kind of nice about sinusoidal functions. Okay, so let's graph. And it says I have to graph it over 2 periods. No, that's 4 periods. 4 periods, but from -2 pi to +2 pi. All right, so I drop a pi on there. This would be pi over 2. And you guys would agree that those would be quarter pies? Right? So pi over 4, 3 pi over 4. So again, like this is the best that I can do, folks. Okay. Oh, I gotta go backwards. Oh, see, I did it wrong again. And that line shouldn't be there. It's a little wonky on this side. Whew. A little white out. It's a little wonky, so no judgment here. Okay. Now I got liquid paper on the tip of my pen, which is stopping me from being successful in drawing that tick. Okay. Let's graph. Oh, I didn't do my...
What's going to left negatives?
Yeah. Thank you. Okay, I got to graph with something else because I screwed my blue pen up. All right, I'm going to start at 0, 0. I'm pointing to it. 0, 0, you just can't see. And then at quarter pi, I'm at 1. And then at pi over 2, I'm undefined. So, not to ruin the surprise, but these are going to be asymptotes because they're undefined. So, if you remember from grade 11, asymptotes have to be drawn in with a dashed line because they don't exist. They're not part of the graph. So it's really important that they're a dashed line. Okay, so what that means, what do we know about asymptotes? The graph approaches them, but never, exactly, gets infinitely close, but never crosses or touches them. Okay, just so we know the rules. Sorry guys, I'm not gonna, you guys have the 3/4 pi, which would be right here. I'm at a -1. At pi, I'm at 0. And at 5 pi over 4, I'm at 1. At 3 pi over 2, I'm undefined again. And then at 7 pi over 4, I'm at a -1. And at pi over 2, I am at 0. Okay, and then on this side, at quarter pi, I'm at -1. At pi over 2, negative pi over 2, sorry, I am undefined again. I don't know what that was. Did I lose the meeting? Or someone joined? Welcome to someone who joined. Okay, and then where am I? I'm at 3 pi over 4, so I'm at +1, 0, -1, and then at -3 pi over 2. Again, I'm not really putting a lot of mathy thought into this. I'm just following my pattern. So if this was at -1, this one's undefined. Where do I go? +1, 0. Okay, so is this a sinusoidal function? Does it follow a wave pattern? It can't, because you've got these slices, these asymptotes right in the middle. So this isn't a sinusoidal function. It's a trig function, but it's not sinusoidal. It doesn't follow that wave. I'm going to do this first one here. Remember that you approach your asymptotes, but you never touch them. So you got kind of like this sideways wave going on here. Okay, why didn't I increase this one? Why didn't I put this one up here? I didn't graph it, and my restriction said I'm going from -2 pi to +2 pi. Those were my boundaries. So that's a weird domain restriction, but it says I have to stop at 2 pi. So I stopped at 2 pi. And then this one. Nope, not considered an asymptote. Considered a boundary restriction or a domain restriction. So you kind of have a wave, sort of like, but it's kind of, it's not a wave at all. So this one looks extremely different than your sine and cosine.
Looks like a
Can
weaver.
we get a graph like that on one of our quizzes?
Yep.
Like it goes like this, and then we, like the other one, like.
Yes, yeah, that's actually, you guys did a cubic function, that's what, or a quartic function, yes, but it was a problem set. And you had to do the inverse of it, problem set numero 1 on like page 3, I think, maybe not. Anyway, so here we are with our tan graph. That's pretty exciting. Now, let's talk a little bit about it. What's the amplitude of our graph? Do I have an amplitude? Better question, do I have a maximum?
No.
No. So if there's no max, and on the other side of that, there's no min, do I have an amplitude? No. Right? Because there is no maximum height of the graph, there's no median to measure it from.
Yeah, couldn't you just say it's infinite height, infinite normal, or?
I guess you could say that there is maximum is infinity and minimum is negative infinity. You could say that, but you still don't have an amplitude because you're not hitting a point, right? There's no top. There's no maximum. Period of this function. So you guys are looking for asymptote to asymptote. Pi. Oh, look, you can't see. Let me do that. So when somebody says kiss my asymptote, I question whether they know what an asymptote is. It's a funny math joke. Look it up. It's a math meme, I promise. But you can't kiss an asymptote because you can get infinitely close to it, but you can never touch it. Domain of this graph. Nope. This is the domain that is given, that's a domain restriction. What's the domain of a tangent graph? You could do that, but there's some problems. If we do it, the domain doesn't exist. Where does the domain not exist? At the asymptotes. So let's write a general solution for the asymptotes. So theta, so almost like a restriction on the domain. Where theta cannot equal, where's our first positive asymptote at? Pi over 2. How often do my asymptotes occur?
Every pi.
Every pi. So we're going to add pi k, where k is an element of the integers. And notice that I said theta cannot equal, because it doesn't happen. The domain does not occur where the asymptotes are. Range of the... Yep. Zeros of the function. Okay, yeah. So your zeros are your x-intercepts, right?
Yeah.
So we have to make a domain statement, because the other one, there was just one, because it was the wave it crossed. No, that was the y-intercept, sorry. The zeros of the function happen multiple times. We created a general solution here. So our first positive one happens at pi. Where does our next one happen? At 2 pi. So what are we adding? Pi k. So do you see, like...
Wouldn't our first positive 0 be at 0?
Yes, you could totally do that too, Cam. Yeah, you could totally put 0. It kind of feels funny putting 0 plus something. So I would totally accept 0 there as well. That's a great thing about general solutions, is we can make many of them. Y-intercept. Note there is. It crosses at 0. Asymptotes.
Every pi, so 3 pi.
theta does not equal pi over 2 plus pi k, where k
It's
is an
just-
element of an integer.
Exactly. So it's this, but the thing we have to edit is that. Because we're saying where are the asymptotes. Here we were saying where the domain can't be. It's the exact same statement, but we're saying the asymptotes are located. So we do have to put, because we're saying the domain, the asymptotes occur when theta is equal to pi over 2 or any plus pi's after that, or before that. So tangent is a completely different beast. Okay, how do we feel about that? Completely different, completely different. All right, reciprocal graphs. Here we go. So what I did was, I thought this was nice and friendly of me, is I gave you, this is the sine table of values right here, already filled in. That's your sine graph. That's your regular sine graph. And then I put the blank table over here so that it's really easy to do the reciprocal of it. Does that make sense to everybody? Okay, so let's start at the top. At negative 2 pi, if it was 0, what's the reciprocal of 0? Undefined.
Undefined.
Beautiful. So proud of you guys. What's the reciprocal of 1? Also 1. 0? Undefined. This is a pretty exciting one. Negative 1, what's my reciprocal? Negative 1. Because if you flip it, it's still the same, right? That's the nice thing about ones. Undefined. What am I doing? 1, undefined, negative 1, undefined. Holy Hannah, that's a lot of undefineds.
So
Half
half this graph is just an asymptote.
this graph is just asymptotes. All right, here we go. So 0.
Can't we just make graphs out of asymptotes? Can you make a box with using asymptotes?
Can you make a box?
Yeah, like have a box in the equations. Like
Yep.
circles.
We won't do it this year because we'll only do 2 vertical asymptotes, 1 horizontal. But you can get into limits where you have limits going 2 horizontal ones. So welcome to calculus.
Oh,
There's a negative sign in there, but it doesn't really look like it. Okay, and then I've got 1, and I have negative 1. Getting really good at doing these graphs. Okay, so let's, you know what I'm going to do? I got my handy dandy ruler. I'm going to do all my asymptotes while I have my ruler out. Feel free to follow along. And again, I can't stress this enough that they do have to be dashed. They have to be broken because they don't exist. If you put them on as solid lines, I have a ruler and none of these lines are straight. That's my favorite part. They're really crooked. If you have a solid line, I have to deduct marks for that. Because it doesn't show you understand that asymptotes are an imaginary boundary. Those lines are a little crooked. I got better in the negatives. Okay? Here we go. At pi over 2, I'm a positive 1. And at 3 pi over 2, I'm at a negative 1. And at negative pi over 2, I'm a negative 1, positive 1. You're like, Scallion, that is not enough points. That's not enough points to figure out what this graph looks like, because I only have 1 point in between my asymptotes. And your gut reaction is to do a tan graph through those, and you'd be incorrect. So what I need you guys to do is do a little bit more information. So let's go here, and we'll see the pattern, so we don't have to do them for a lot. So let's do pi over 4. What is sine at pi over 4?
1 over, like,
1 over root 2 is on the original graph, so it would be just root 2. Just root 2. So if I was to do, so this would be root 2, and I don't know about you guys, but I have no clue what root 2 is in decimal form.
1.4.
I love it. Of course, Het knows. 1.41. All right. And so this is 1.41. If we went to 3 pi over 4, what's sine at 3 pi over 4?
Root 2.
Root 2 again. Okay, so if I were to plot these points, they would be greater than 1, right? Like, so this one would be like a little bit greater than 1, like here and here. Can you graph that now? Parabola. Okay, so we got that one down. That makes sense. Xander's like, it does not make sense. So let's do when it's a -1. What do you anticipate to happen?
Gonna look the same as our positive one, but be inverted.
Yes, perfect. Because at 5 pi over 4, this is going to be a negative root 2, which is a negative 1.41. And at 7 pi over 4, that's also going to be a negative root 2, so a negative 1.41. Sorry guys, you can't really see that. And so again, this is going to be the same sort of parabola, but it's going to be pointed down. So if you ever get stuck with a table of values and you do not enough information, don't be afraid to go back and add in stuff to give you a better picture. So what do you notice about this? If it's a -1, I've got a parabola that opens downwards.
Down.
Down. And if it's a +1, oh, Scallion's losing marks for that. What did I just do here? I crossed the asymptote. Half a mark deduction. Please make sure your notes look better than mine.
So if we were to graph and we just did that without big points, would we lose marks?
Do you have 2 points labeled on your graph?
For everyone's parabolas, or just the overall graph?
Remember, this is one graph. This is cosecant graph. This is what a cosecant function looks like.
So if we just put the points for 2 of them, we just did the rest by hand.
Mm-hmm. You're golden. Don't overmath it. This is what I was saying this morning. Don't overmath it. But I wanted you guys to do those points just so you knew why I was doing up parabolas and down parabolas, right? So your notes are complete. Okay, let's talk about an amplitude.
None?
None. Period.
Every time.
Pi. Domain? Oh no, it's not pi, guys.
Oh, okay.
Because what happens in between your asymptotes? You get a downward parabola.
Yeah. Another problem.
Are they all downward parabolas?
Oh, 2 pi.
You need the upward parabola and the downward parabola to complete the set, right? That's when your pattern repeats. Where does that pattern repeat? So it's not pi, it's
2 pi?
2 pi. And you would expect that because the sine period is 2 pi. Oh, sorry, Kira. I'm all out of sorts. People are turning off my thing. And domain for this graph.
Negative and positive.
When?
When it doesn't equal all the way on.
Pi plus pi k.
Do you guys find general solutions easier to do now? Like they make more sense? Like it was, you guys picked that up right away, right? Like it happens every pi. Range. Okay, I agree with you, but what are we going to do there?
-1,
Y cannot equal.
0.
Okay. So let's go back here. Does it include +1 and -1?
Yeah.
In the graph, it totally does. So my restriction have round brackets around it. And so I'm saying y cannot equal anywhere between, but not including, -1 to +1. So that area of the graph is fresh and clean. Do you guys see what would happen in the graph here? Isn't this just the space? The void is where your sine graph would occur. I've got a picture of it where it graphs the cosine graph, and in dashed lines it shows you the sine function. So this void right here is where your sine function lives. I thought it was cool. Never mind. Zeros?
None?
None. And again, you guys know that you can't just leave that blank. You'd have to write the word none. And y-intercepts?
None.
None. There's an asymptote there, so I hope there's none. Asymptotes.
And that's every pi, so 0 plus pi.
So, oh, you want to do it this way. 0 plus pi k, where k is an element of the integers. Could I have picked pi to do it from too?
Yeah.
Would have been perfectly fine. I could have said 2 pi, not 2 pi, 2 pi. You know, like, so what you put here is important, but it's not critical. And now I see that my secant and my cos are on this page, but they're for the other page. Goodness gracious, Scallion, this was a terrible photocopied booklet, just for the record. And it's majorly my fault. Okay, so this is...
I'm sorry, can you go back to that table?
Yeah, just let me write this down before I forget.
Okay.
Sorry, I just get confused. I get excited, Kai. I just want to write all the math all the time.
I only just finished drawing the parabolas because I was trying to do the math myself.
Yes, fair. And I go quite quickly, and I apologize. It's just and I talk a lot, and your videos are really long. Your lessons are really long. It's painful. And I ran out of water. Am I good to flip? Almost.
Yeah.
Okay, cool. All right, so I did the same thing with cosine, where I gave it to you. Like, that is our cosine table. So now let's fill in our secant table. At -2 pi, it's 1. And if it was 0, now it's undefined. If it's -1, it's still -1. At pi over 2, it's undefined. 1, undefined, -1, undefined, +1. Well, that's exciting. You okay, Xander?
Yeah.
It was a big sigh. That was like a...
That was more of an exhaustion sign than a...
Okay, then this is too hard?
Yeah, this should be less than right drawing.
Okay. Okay, so let's graph these. Do you guys anticipate a problem? I do. Okay, so I'm going to drop my asymptotes on first because I've got them. I wonder if I have those graphs somewhere. I must have them somewhere. I just want to show them to you because they're pretty cool. And I peeled them off the internet. Like, they're not super secret or anything like that. And I wonder if you guys can dig deep for me in your memory. On the original graph, when I do reciprocals, this would be chapter 6. You've probably all emotionally blocked it out of your head. Chapter 6 in grade 11. Your asymptotes occurred at a very specific point on the original graph.
Yes, interesting.
Xander did grade 11 last semester, so we'll give him a...
I
You still get a gold star, like definitely a gold star. The fact that you pulled that out, like, because we all block chapter 6 out of our heads, like that's the way it should be with chapter 6. The fact that you pulled that out. So you can anticipate that if I have, and this makes sense, these would be your x-intercepts. And what you notice is when you go to the new graph, they become your asymptotes. It's not crucial that you know that. You can do the math and it's going to give you the answer of asymptotes. So the math won't lead you wrong there. But it's kind of cool. Kind of cool. Hey, where does a cosine graph start at? Max, right? Where did a sine graph start at? Median. I guess it's present tense, not past tense. All sine graphs start at medians. So a median is at 0. And that was an asymptote on the last graph. This one starts at a maximum, so I have no asymptote on the y-axis. I don't know. Just linking ideas together. If you get it, you get it. If you don't, you're like, that's too much, lady. Too much.
I'm fine.
Yep.
Can I go now?
Yeah, of course. You go anytime you need to. Are you going to get your grab photos done?
Yeah.
Yay! So exciting. Such a fun time of the year. I mean, you guys kind of get a raw end of the deal, it being COVID and everything, but still pretty exciting, pretty exciting. Dominic, did you get yours done?
No, this afternoon.
This afternoon?
I had
Okay.
mine.
Jaden, did you get yours done?
I had mine yesterday.
Yesterday? Xander, you had yours yesterday?
I had mine this morning.
Oh, you had yours this morning? See you. Okay, so we're in the exact same predicament as we were before with this. What do we know? We know we don't have enough information, so I'm going to go to pi over 4. What's cosine at pi over 4? Root 2 over 2, right? So flip it.
One.
No, that's the tangent, right? So it's the exact same thing. It's root 2 when you flip it. And that we said was equal to 1.14 because we have Het in the class and she's going to help us out. So remember that on this side it's going to be positive because pi over 4 occurs in quadrant 1. And then if we go backwards, negative pi over 4, what quadrant are we in? Pi over 4 backwards, what quadrant are we in? Pi over 4. We're in 4.
Oh.
It's okay, Xander's having a moment. Chapter 6 broke your brain. I'm sorry, I brought it back up. So this one's also going to be positive because we know cosine is positive in quadrant 4. And now, but okay, so don't think too hard about it. At pi, this would be 3 pi over 4. Nope, that'd be 5 pi over 4, sorry. 5 pi over 4. I put this in the wrong place. This should be pi over 4 right here. And that should be root 2, and that should be a positive 1.14. This should be 3 pi over 4. But 3 pi over 4, I'm at a negative 2, so that's going to be negative 1.4. This one would be 5 pi over 4. This will also be a negative root 2. And then this one would be 7 pi over 4, which would be a positive root 2, which is a positive 1.14. Pardon? Is that what you need? So here, wrapped around the pi's, like there's my pi, on either side of the pi are the negative 1.4s. So it still follows the same pattern as our sine graph. But where they sit is very different. Yeah?
It's not for the half over 0
No, I wouldn't have that.
Oh, so you just cut it in half?
You cut it in half. This one didn't have the restriction, so I was just going crazy. But so this one would look like if I had the restrictions, it would look like that. And again, make sure that you have arrows on them. I don't know, I might be half tempted to deduct myself a half mark on that because that doesn't look very parabola-like.
You got to use it all. It's more parabolas than I've ever do.
True story. This one's pretty good. This one over here, pretty good. This one over here, not so much. I didn't even hit the point. Like I used to like to blame it on my Mimeo, but it's totally me.
It's best fit curves.
I love it. Best fit. I don't think that works. Okay, let's get through the table. I'm asking things about secant. So remember, this is the way I remember how to do my graphs. Like if this is a secant graph, I know that it's a reciprocal of cos. Cos starts at a maximum. So this is how I know this is not going to have the asymptote on the y-axis. As soon as I know that, I can do the pattern to get my graphs. And I know that a sine function, because it starts at a 0, has an asymptote on the y-axis. Because don't these look almost the exact same? And same with the waves. The waves look the exact same. But it's where they start, where that maximum starts and where that median starts. Okay, let's do that bottom table. Amplitude, none. Period,
2 pi?
2 pi, because we need both the up parabolas and the down parabolas to make a period. Domain,
Negative k to infinity with
with what restriction on it?
beta can't equal the first one. 2 pi?
Pi over 2.
Pi over 2 plus pi.
Pi k,
KEI thing.
kei thing. Range,
Negative. Oh, you're still negative k to positive k with the pi. Y can't equal 1 negative 1.
yeah, but remember they have to have round brackets on it because the ones are included in the solution. Hey, you are also getting your hair done and grad pictures, and it's my favorite time of year. X-intercepts,
Yeah,
y-intercept,
no. 0.
Nope.
1.
1. Asymptotes,
Whatever the first one's.
but what changed? This one has the cannot equal, this one is equal, because you're saying where the asymptotes are. And here this is a restriction saying where the domain does not exist. Okay. All right. We're getting there, guys. We're getting there. Kai? Am I good to flip the page?
No.
Okay, fair. You know what? I can't pause the video. Kai's finishing. I'm gonna run and just put some water in my water bottle. There'll be a long pause on the video. Okay, Kai, are you good if I flip the page?
Yeah.
Yeah. Okay. Guys, I didn't fill in the tangent chart for you, and it's giant. But we're good, because we've done it from our first page of notes. You ready?
Yeah.
Actually, you got no idea what's going on.
I know.
Yeah, it's okay. You know what?
Go home and like.
Yeah, I love it. I'll just go home. Negative. Let's do our positives first. You're just pulling the information off the first page. So somebody just needs to read it out loud. At 0.
Yeah.
Is it 0?
Yeah.
Okay. Pi over 4?
1.
1, pi over 2, undefined.
Negative 1, 0, 1, undefined.
Oh, I was going to put an angle there. What's the pattern?
You can do the rest of it here. Negative 1, 0.
Okay, right? So we're just following the pattern. So if we have a positive 1 and a 0, what's this one?
Undefined.
What?
A negative 1.
Negative 1. You need a set in there, right? So then we're undefined.
1, 0.
1, 0, negative 1,
Undefined.
undefined,
1, 0.
1, 0. Okay, so again, we just did that one. We just learned about the tan graph.
Wouldn't the undefined ones turn?
Ah, so remember what I did with this undefined one? I don't know where my first positive undefined is. Hang on. I said that this one would be the 1 over 0. You guys can't see that. 1 over 0, right? So when I reciprocate that, what does it turn into?
1. So 0 over 1.
0 over 1, which is?
0.
0. Xander's stuck in a loop. Flip it, Xander.
Oh.
If we flip it, it's going to be 0 over 1,
That's in my copy of data.
right? So that's the reciprocal function. Okay, so here we go. Let's start from the top. Zeros turn into undefines. 1 is still 1. Undefined turn into 0. Negative 1 is still negative 1. That becomes an undefined. 1 is still 1.
0.
Maybe if I zoom
Wait, so
out,
that means it just moved down by 1?
it shifts, right? It doesn't move down, it shifts over. Where's your first asymptote, Xander? Where's your first asymptote on this graph?
Oh, it's going to be negative 0.
Right? So 0 was 0, 0. Now I've got an asymptote there. So things get shifted. So pi over 2 was my first asymptote. That changes to a 0 of the function. Negative 1 is still negative 1. Always makes me feel good when things stay the same. This is 1. This is a 0. This is a negative 1. And that's an undefined. Okay, what do we anticipate the shape of this graph look like?
The same for
Yeah.
Backwards.
Backwards. That's correct. It's the tan graph, but backwards. And then we have 1, and we have negative 1. Are you guys getting really good at doing your increments on these things? Sometimes. Well, we've seen my parabolas, so I'm not one to judge. Let's drop our asymptotes on first, because I have my ruler. And I prefer not to pick it up multiple times. That's nice. Where are my asymptotes all at? Pies, just like the quiz. Okay. So my asymptotes are on there. Done with that. So remember when we did it, the tan graph was here, and then it went up to a maximum on the right-hand side. Right? You guys would agree with that? So my 0 is at pi over 2 now. And then at 3 pi over 4, so on the right-hand side now, I'm going to a negative. On the left-hand side, I'm going positive. So now I have it falls to the right now. Before it rose to the right, in the reciprocal graph, it falls to the right. Kai, what were the words that you used when you told me what you anticipated the graph to be?
Backwards.
Inverse of tan.
Backwards. It's doing, yeah, I just couldn't remember what you said, but it's a good descriptor. So a regular tan graph rises to the right, a co-tan graph falls to the right. Again, your table of values will never lead you wrong. If you do the table of values, you don't have to remember anything about how these graphs look. But if you know those, you'll be able to see if you did your math correctly and if it follows that same sort of trend. So there's my other 0. I fall to the right. There's my 0. I fall to the right. I'm just going to keep saying it over and over again because maybe that'll stick in your head. So on a cotan graph, I'm falling to the right. I might deduct myself a half mark here because I'm moving away from the asymptote. Does everybody see that? It's bad when I have to deduct myself marks, but not super shocked by that. My drawing skills are slim to none. And I didn't even hit that point. All right, somebody needs to send me back to graphing school. So the graph is like a mirror image of what it would be on a regular time graph. Okay, now we're here to fill out the table. Good times. Amplitude? None. Period? Back to being pi. It shouldn't change whether you reciprocate it or not. Domain?
Yeah.
The negative infinity to positive infinity thing,
Theta.
where theta cannot equal
0 plus pi k, yeah, thing.
Beautiful. So how do you guys feel about that? Cam, you had said that. You had said my first positive asymptote was at 0. Do you like that better?
Makes more sense.
Makes more sense to you? It's okay if the pi makes more sense to you. Either one is 100% correct. Range.
Make it thing positive.
That's nice. Zeros of the function?
A lot of zeros.
Pi over 2 plus pi 8.
Again, a general statement because it goes on forever, right? And there's multiple x-intercepts. Y-intercepts? None. We got an asymptote laying on the y-axis there. And then the asymptotes?
Other thing with the main is equal sign.
Exactly. Same thing, but just with an equal sign. Oh, thank goodness. Oh, thank goodness we're done. Okay, but here's the thing. In your assignment, Kai, I will come back to that. In your assignment, oh, you're done? Yay. You have transformations on your graphs, right? So what does that do? I would recommend that you use the table of values. And then when you feel comfortable with it, then go and try that. You guys have a lot of graphs to do on this one. So good luck.